Welcome back, learners. So now to wrap up everything and having to go through step by step what transpired in the entire lesson. So we looked at the parallel circuit as our main idea. Then from there, we looked at the components of an electric circuit, and then lastly, look at the diagrams or the circuit diagram that were connected in parallel. We used words such as electrons, parallel circuit, electric circuit, and electric current, whereby electrons, those are now negatively charged subatomic particles, and a parallel circuit is a type of a circuit that provides more than one pathway, remember, emphasis here, more than one pathway for electric current to flow. We also looked at electric current, that's now the conducting pathway for electricity, and then lastly the electric circuit, that's the conducting pathway for electricity, and the electric current, that's now the movement of electrons through the conducting wires. Whenever you think back of this lesson, these are the most important things that I always want you to remember about this lesson. That's number one, an electric current is the movement of charge in a closed conducting circuit. Number two, that an ammeter is a measuring device used to measure the electric current in the circuit. Remember that the ammeter must always be connected in series in any electrical circuit. And then, as more resistors are added in parallel, the total resistance of the circuit decreases. So because the total resistance of the circuit decreases, then the current strength is going to increase. So as we add more resistors in parallel, we are actually decreasing the effective resistance of that circuit, and by so doing, the current strength is going to be increased. So, with all of that said, this is the question that I have for you. The question says, what happens to voltage in a series circuit and also in a parallel circuit? So what happens to voltage when looking at a series circuit, and also what happens to voltage when looking at a parallel circuit? You're going to answer this question for me, and I will see you next time. Until then, goodbye.